Hello, good afternoon, everyone. Good afternoon when you're in Europe. Good morning if you are further away in the States. Good morning, Bill. All good? All right.
Yes.
This is the third lecture that we provide based on the masterclass, the Management Masterclass that we will deliver on May 7th. And the master course following that, it's an online course that we will present on the 20th of May. Sorry, so you can follow two more exciting programs with us based on what we are going to show you today.
All right. Okay. Thanks everybody for joining, whether you're here for the first, second, or the third. So the agenda today is a welcome, highlights from part 2, agony of the last straw, recent, and then closing. And again, we'll provide you the links to this session as well as the first two. And our recommendation is every time you watch them, it'll make more sense. Just leave it at that. And all right, so here's the abstract for part 3. Before his death in 1993, W. Edwards Deming provided a map of theory by which to understand the organizations that we work in. He was well aware of the challenges that organizations face in their, what I call organizations as usual mode of operation. He shared simple explanations to help us envision organizations as unusual. Sure, I said we have to solve problems, certainly stamp out the fire and get nowhere. Stamping out the fire puts us back to where we were in the first place, which is not improvement. I refer to as a tail. It's like a cat chasing its tail, not realizing it's your own tail you're biting. And practicing organizations as usual, resources, which are time, energy, equipment, those are all resources, are allocated to firefighting, attempting to lower things gone wrong under such contingent circumstances. How much value is given to activities for prevention, if not seeking opportunities for investment, where in efforts to improve interactions will have a superior return? Organizations as unusual, guided by Dr. Deming's distinct theory of management, offer unlimited opportunities to both prevent problems and seek opportunities for investment. And that's what's essential is the shift we're talking about has two opportunities to help organizations. And one is to prevent problems, which are organizations as usual. Major focus is solving problems. And you can think of it as the time saved in solving problems, not having to chase your tail, opens opportunities to look for where can we spend time to save time? Where is an ounce of prevention going to gain us a pound of cure? That type of thinking does not happen in organizations as usual because we're so busy fighting fires. Okay, so the influencers, 3 primary ones. One, Junichi Taguchi, who I met in 1987. We'll look at his work today. Dr. Deming, who I met in 1990 when he was 89 years old. And the third, Russell Lakoff, who I met in 2003. And he and Dr. Taguchi visited Rocketdyne several times. Actually, Dr. Taguchi visited us 3 or 4 times. Dr. Akoff once or twice a year for 4 or 5 years. All right. So highlights of part 2. The Six Sigma methodology is a methodology for continual improvement aimed at reducing variations and defects in processes its objective is to achieve a high level of quality by limiting defect rates to less than 3.4 defects per million. And what I mentioned last time is embedded in Six Sigma is a focus on meeting requirements. And the idea, and that's what's known as acceptability, it's saying, to say from a quality perspective that something meets requirements is to say it is acceptable. I will take it because it meets the requirements. Six Sigma quality is not about desirability, which is going beyond acceptability. And so part of the limits of acceptability is, part of the challenge in tail chasing is if you're striving for zero defects, once you get to zero, if you got to zero, you'd have nothing to do because you're done. Well, desirability thinking, which we'll get into more detail today, solves that issue. Another thing we looked at last time is the difference between accuracy and precision. In the lower left, it's low accuracy, low precision. So this is shooting darts or shooting at a dartboard or a target, and there's a lot of scatter around the bullseye, a lot of variation, and low precision, low accuracy. So what is high accuracy? High precision is a tight cluster around the target, right? Low accuracy, high precision is a tight cluster, but not on the target. And what I showed last time, that's what Six Sigma is about. It's about precision, but not accuracy. And what I'll clarify today is acceptability is about meeting requirements. It's about looking at items. It could be modules of software, pieces of hardware, but it's looking at them separately and saying that is good, that is good, that is good, that is good. It is not looking at how they come together as a system. Right? Embedded in Dr. Taguchi's work, when you're focusing on an ideal value, an ideal parking spot. See, acceptability would say, I'll take any parking spot in the mall. Desirability is saying, I want that spot because it's in the shade, it's closer to the door. And what you're doing is selecting that spot based on a view of if it's more than a spot. You're saying, of all the spots, the reason I want that one is because it offers an advantage. That's a systems view. When you select a specific doctor, not just any doctor, that's a systems view. And this is not to say acceptability is bad, but acceptability is not desirability. Organizations as unusual understand the difference. Okay. So I looked at, in the first module, there's an exercise with the Mentimeter asking people if you had a choice of 4 suppliers of tubes, just thinking of short metal tubes, where the only characteristic that mattered was the outer diameter. And I said, we've got these 4 distributions coming from 4 suppliers. If they are equal purchase price, equal delivery schedule, guarantee 0 defects, and the distributions never change shape or location, who would you buy from? The majority of people, in asking this question since 1995, would select 4, even though I call out ideal as the preferred place to be. Again, the preferred parking spot is desirability thinking. All right, and so given these 4 choices or the option of I'll take any one of them, the majority of people, when I ask this question around the world, would take 4, which is the thinking behind Six Sigma, but not the thinking of Dr. Taguchi or Dr. Deming in terms of looking at things as a system. What Dr. Taguchi is talking about is if you aren't on the ideal value, then there is an extra effort required in putting things together. And so if you cut a piece of wood to the target value at home in the garage, we draw the line, we aim for the line. Why do we do that? Because if that piece of wood is a little bit too long, then it has a consequence, which could be the lowest curve, maybe not too much, right? And so if you're putting that piece of wood on the wall and there's nothing on either side, well, then a little bit high, a little bit low may not matter. But if you're putting that piece of wood into a system, a piece of furniture you're building or a wall you're building, then having it a little too short, a little too long has perhaps a large effect, which is the long dash line. That's Dr. Taguchi's thinking that I got exposed to in the mid 80s, that how we meet requirements might matter. And the point I made last time is that we understand that blue curve when we are working at home in the garage, or when we're planning any activity on our own, where we're making sure that the components not just meet requirements, but we're paying attention to how well they meet requirements, which again is like saying, I want that surgeon for my wife's operation, or I want that parking spot, or in selecting fruit is saying, I want that orange because it's the juiciest for what I'm using it for. Example from last time was if you're landing an F-18 fighter plane on an aircraft carrier and there's not a lot of space left and right, then you're, as the pilot, he's looking at a curve, or she is looking at a curve which is very steep, right? And on one side I go into the ocean, on the other side I run into something. But if you're the pilot landing a space shuttle, you've got a lot of space on both sides of that runway, which means a little bit off the left, not so much. But in either case, what we're saying is, first of all, we're saying desirability is I have a preferred value in mind. And what the blue curve is saying is, how much does it cost me? How much, financially, how much extra effort is required to not be on the ideal? And the bottom curve says, oh, not so much. And the top curve says a lot. And this is what Dr. Taguchi explained to me. He explained to me, gosh, 25 years ago, he died in 2012. When I pushed him on these blue curves and who uses these blue curves, he said, no company in the United States uses these blue curves. I said, well, then who uses them? He said, the leading users in the world are Toyota and Denso, which is a major supplier to Toyota. And I said, how do they use them? He said, they use them to guide their investments. Because the idea being, why would you make the variation narrow if it doesn't have a big consequence downstream? That's investment thinking. The idea that we would take these curves and be on target, and we're paying attention to how much effort does it take to put on target, and the blue curve is telling us how much are we saving. That's a systems view.
Yes, to add a little practical view on it. So if you are a manager or if you are a consultant and you walk into a factory, I know some of you do that, you go to a customer, you open the door, you go into the factory, and you hear bang, 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 zzz, zzz, zzz. Well, that's the practical signal that they do not use Taguchi's curve, because they're going to assemble things and they do not fit. Operators cannot help it. They try to do the best they can. Team leaders try to do the best they can, but the management needs to be aware of the banging as an indicator that something is wrong in managing the system. Thank you, Bill. Continue.
Yep. Yeah, what I talked about last time is hearing 15 years ago from a senior engineer at one of our big auto companies in the States. And he said that at the end of the assembly line, they have a long piece of wood that is covered with carpeting that they use to get the parts to come together. And they call it the enforcer. And what I'll share with you is what we did at Rocketdyne to eliminate the need for those things.
Force things together.
Yep. All right. So last time we looked at, again, in the second session, we talked about category thinking, continuum thinking. Category thinking is like looking at things as being good or bad. It's absolutely good, absolutely bad. In doing so, our thinking is looking at things in isolation when we say that's good. It's good versus bad, smart versus dumb. Continuum thinking is where desirability comes from. And it's not about good and bad. It's about degrees of good. And so if your quality system is about good versus bad, this is what was bothering me in my 26 years in the aerospace engineer industry, is that why didn't we work on things that were good? Because good was as good as it got. The system was designed to stop at good. Again, today I'll show you there's more to do. But in a continuum mode, you don't stop at good. You stop at, I can continue to improve, but the time I'm spending and the energy I'm spending has to have a corresponding benefit. That takes a systems view.
To add to that, to make it a bit practical, if you are doing internal audits, I recently posted a few articles on LinkedIn about auditing. In a lot of companies, auditing is checking. It's good or it's bad. It's in the limit, outside the limit. Even auditors, internal auditors walking with a piece of paper and questions and tick boxes, that's not auditing, that's checking. Auditing is finding the big picture of the system. So you need continuum thinking.
Yeah, and again, when I show the 4 different distributions of the tubes and say, who would you buy from if it's equal price, equals delivery schedule and everything, category thinking would say, I'll take anything that meets requirements. But that's rarely the case. Continuum thinking is when you see them as different. But now the question is, are we focused on the most consistent to each other, which is the narrowest distribution? Or are we focusing on how close they are? And that's precision. Or are we focusing on accuracy, which is where Dr. Taguchi is coming from? Six Sigma quality, as shown by this metric we looked at last time. Capability indices are about focusing on precision, not accuracy. Right? And so again, there's more details on this in module 2 in our second session. And so the Mentimeter used last time was asking the attendees to estimate the CPK values of these 2 different distributions. And it turns out both of these distributions have a CPK of about 2, but notice they are at opposite ends of the requirements. But again, within Six Sigma quality, we're not looking at things as a system. So even though they have the same CPK, and with a Six Sigma mentality, we'd say it doesn't matter who we buy from, right? Neither one of them is, in neither case are we looking at what's the ideal value, the ideal location. So what's missing? There's no reference to an ideal value, which means we're looking at things in isolation. Again, maybe it doesn't make sense to do more than that. And in organizations as unusual, we think about options. What's the ideal value? But so far, that's the whole acceptability thinking. All right, new material. Agony of the last straw. So a true story, I was flying home. At the time, I was Rocketdyne, the rocket engine manufacturer here in Los Angeles. I worked for 26 years. We were part of Boeing for 9 years. And so during that era of Boeing ownership, I was traveling all over the country doing seminars for airplane operations or rocket operations or military operations. And on one of the trips, I bumped into an executive of a major European airline. He saw I had a Boeing shirt on, and he says, hey, we buy your airplanes, we exchange business cards. He asked me what I do. I said, I do seminars. And he said, what are they like? And I said, I ask people questions. And he said, well, what kind of questions do you ask people? So I said, I'll give you a simple question. I said, what would it be like if you worked in an organization where everyone thought the last straw broke the camel's back? And he looks at me and he says, I wouldn't want to work there. And I said, why? He said, if I was the last straw, they'd all blame me. This is an executive. And I said, what else? He said, the other straws would stand there watching, thinking they had nothing to do with it. I said, okay, what else? He said, if anyone made a mistake, they would hide it. I said, okay, what else? He said others would make the same mistake. And so I kept asking him, what else, what else, what else, for literally 4 or 5 minutes. And after 4 or 5 minutes of me asking him, what else, he stopped and he said, Bill, he said, that's Lufthansa. That's where I work. That's how we operate.
To give an equation, a metaphor in the Dutch language, for those who want to know, it's like de druppel die de emmer doet overlopen. It's niet de laatste druppel, maar it's the whole bucket, of course, die de emmer doet overlopen. Go ahead, please.
So what I want to do next, and this is covered in great length in the one-day master course, that we're doing on May 7th, and extensively in the master course. And so I just want to, give a highlight here. And so what I would ask people is, imagine you've recently visited an organization, an all-straw organization, which is organizations as unusual. And, which thinks about all the straws, not just the last one. And whereas a last straw organization is organizations as usual, we focus on that last straw in isolation. And so this all straw, last straw is organizations as unusual on the left, usual on the right. And so the scenario I give people is, imagine you've recently visited both organizations for 2 weeks each. For the first week you're visiting both organizations, imagine no one is there but you walking around and you're taking notes. What would you see in that first week as you're walking around? There's no people there. All you know is one has a last straw focus. One looks at all the straws. If that's all you know is one is narrow, one is broad, what do these organizations look like physically? Again, there's no one there in that first week. Then in the second week you're in both organizations, there are people there. So what I ask people to do for the second week is shift your focus from describing the two environments physically to describing the people in both environments. So what comes to mind? What might you see in an all-straw organization, again, where we're looking at things broadly, not narrowly? What might that organization look like physically? Any thoughts there? Fewer walls, okay.
Yeah, Jamal saying fewer walls, more working together.
Okay.
As a matter of fact, I got a comment this morning with the training that here in the office we have all glass windows, so everybody can see everything, so it's very transparent.
Yeah.
So that's indeed fewer walls, so everybody can work together. Less clutter.
All right, and then by comparison, what would you see physically in a last straw organization? Indications of an organization that looks at things narrowly. What do those environments look like?
Anybody an idea? Just shout it out. There's no test. We try to think together. We try to work together.
So what comes to mind there? If we're focusing on that last straw in last straw in our organization, what does that tell us about the physical environment of the organization? Any clues there? All right. Then what are the people like in those organizations? So far I've told you the Lufthansa executive said they would stand there walking around thinking they had nothing to do with it. They would, if they made a mistake, they would hide it. If they had a solution, they would keep it to themselves. Can you think of other characteristics of people in a last straw organizations as usual environment? Any other telltale signs of their characteristics?
In the chat, I read, Bill, slogans on the wall, do it right the first time.
Yes. And then lastly, what would be the telltale signs, characteristics of people in an all-straw organization? What do you think are those characteristics if you were to visit such a place? All right, so in a seminar, again, either a live event like we're doing in May or an online event such as the master course, we give attendees 5 minutes to think about this. We have them share with the people they're in the event with. And so let me share with you a typical set of responses. And if I was to write them all down, go around the room and ask each person, tell me one thing, tell me one thing, tell me one thing, on to the next person. And so typically what I would do is go around the room and get one response from each person in the upper left, and then go to the last organization, then the bottom. And if I translate that into text, here's a very typical set of results, having done this very exercise over 500 times around the world. All-star organization, no walls, well-lit, well organized, not a lot of waste, yoga class scheduled, daycare on site, visible metrics. Last straw, walls, individual departments, separate and distinct work areas, not well maintained, outdated, poor utilization of assets, quality signs, candle lighting, the people, empty slogans, someone looking over their shoulder, dictatorial, individualistic behavior, focusing on quotas, punitive, on a time clock, and the people in an organizations as unusual, on the floor management, open lines of communication, enjoy working, highly motivated, attentive, part of the solution, not part of the problem, smiling. So again, what's neat is having done this very exercise, asking people either online or live to spend 5 minutes imagining what you would see. This is what pops out again and again and again. Well, think about this. Again, another question I've been asking people, this exercise started in 1998. And so what I'd ask people is, what percent of organizations operate in a last straw, organizations as usual mindset? Okay, Jeroen, back to you.
Everybody got the question?
What percent of organizations in your experience operate with a last straw, organizations as usual, have those characteristics?
Okay, then we go to the next slide in Mentimeter. So give your opinion. What is the percentage you would estimate? It's not particularly science, but it gives a good feeling. Last for organizations, 75%, 72%. That's nice. But that's very accurate.
Yeah, that's about what I would expect, right?
Yeah.
You've seen this, right?
Yeah.
All right. So then,
Yeah.
all right. So
maybe I influence everybody because I typed in 75% in the chat. So maybe people saw that and thought, okay, maybe he's right. I don't know.
No, Bart, what's funny is most often people say the majority, right? And once within Boeing, there was an executive sitting in the front, and he said about 20%. And everybody behind him, when they saw that, just looked up and thought this guy was crazy, right? Right? And at the end of the class, the executive came up to me and he said, his comment was, oh my God, he said, I said 20%. I was so off. All right, so the big question then is, what keeps organizations as usual, last straw organizations, if the majority of them operate under that model, limited by that thinking, what keeps them in business?
Any thoughts in the chat? You can share it in the chat if you like.
Let me ask, Jamil, having completed the master course, remember my answer, what keeps them in business?
Yeah, I was looking for the mic. So probably that the rest is doing even worse.
That's right. My explanation to Boeing executives, what keeps us in business? I said lousy competition. Meaning that if you're spending so much time fighting fires, which is focusing on the past to get back to today, what keeps you in business? Everybody else does the same thing. All right. Now let's look at resource management. So in your respective organizations, how much time is spent in meetings every day discussing parts, tasks, milestones, efforts, etc., which are good and completed on time? Okay, Jeroen, over to you.
Yes. Next slide. There we are.
So the question is, how much time do you spend in meetings every day discussing parts, tasks, milestones, efforts, which are good and completed on time?
Yeah, so it hardly ever happens. It's 0 or close to 0. So once in a while, that's a small amount. When it's a kind of mainstream topic, we get to medium amount, and large, of course, if we are continuously working on task list efforts and so on.
Yeah, and in asking this question, once to a room of 50 or 60 people working on Boeing airplanes was a monthly production meeting. And for the first 2 hours, that's all it was scrap and rework and behind schedule deliveries. And when I get up to speak, I ask this question. I said, how much time do you spend every day discussing parts that are good that arrive on time? People in the front row said 0. And I said, why is that? And the answer was, well, if it's not broken, don't fix it. I said, well, what if you drove your car with that thinking? When would you put gas in it? And the response was, when it runs out. And if you use that thinking at home, when would you call the plumber? After the problem occurred. And if you use that mindset, when would you go to the doctor? When I'm sick. So what you're doing by focusing on this category thinking of good versus bad, and not focusing on the good, but focusing on the bad, what are we doing? We're creating bad.
So with this example, when I gave some practical example, like walking into a factory, hearing banging, audit reports that are just checking things, notes that from a meeting. You can, by reading the notes, you can understand what type of organization it is.
Yep. Well, the analogy I use is, it's like driving your car without a gas gauge. And so it could be Bart and I are out someplace. Bart's driving, and I say, Bart, let's get gas. And Bart says, Bill, we have gas. How do you know? Well, the car's still running. And then we run out. And how are things prior to running out? Everything was fine. Everything was fine. And now we're in crisis mode. Well, organizations as unusual use gas gauges. They use continuum thinking. They know the difference between having gas. Having gas doesn't tell me, all that having gas tells me is that it's good. It doesn't tell me how good. And so one of the things I saw at Rockathon is if we started to use gas gauges, we could have fewer problems. But the problem is convincing people to focus on things that are good in an environment of only working on bad.
Which is precisely what you're not doing at home. Because
yes.
You want to go on a holiday and you want the car keep running and not getting out of gas. So you think ahead.
All right. So next question, going back to Mentimeter. Imagine being in school. It could be grade school or college. And the question is, how much time do you remember spending studying for a final exam, reviewing questions from the weekly quizzes in the midterm, which were answered correctly? So if you're studying for the final, and imagine you've got weekly quizzes, you've got a midterm, how much time would you spend studying the questions you got right?
Yes. Going back. Question 3. How much time is spent preparing for the final exam, reviewing questions from weekly quizzes and the midterm, which were answered correctly. And there we go. This is from 0 to large amount. It seems that small amount of time has a preference. All right. Thank you.
Okay. And so I find is the numbers, the percentages on those two questions tend to be the same, which means whether we're studying for the final or we're in a last draw environment, we tend to focus on the things that are bad to make them good, but then we stop at good. So there's two things there. One is, if we got to good, there'd be no reason for improvement. And two is, we're waiting for bad to happen. And so I liken it to, driving down the road and making a right-hand turn, focusing on the things that are not going well. That's organizations as usual. Focusing on the things that are going well, which could be going to the doctor once or twice a year for a checkup, right? That's prevention thinking. And so the mindset of organizations as usual is, if it's not broken, don't fix it. A road less traveled is to figure out if we can use continuum thinking and move from good versus bad to degrees of good. That thinking shift allows us to see trouble happening and preventing that trouble in the first place. Huge advantage. So what I'm looking at is not quality management, but how are we allocating our resources? How are we spending our time, our money, our energy? Where's our thinking? Is it focusing on opportunities for investment? Where can we spend $1 to save $5? Or are we trying to find out why the car doesn't run anymore? So we have resources coming in. They are integrated, converted into products and services, using tools and techniques. So tools and techniques could be run charts, control charts, SPC, process flow diagrams. Nothing wrong with them, but tools and techniques, tools are the implements that are used to complete tasks. Techniques are the methods. They don't change our thinking. So organizations as usual, use tools and techniques, but they haven't figured out the value of working on things that are good.
Can I add to that?
Sorry. Go ahead, Jeroen.
Can I add to that from the practical point of view as consultant or managers in organization? We are aware that a majority of organizations want to comply to ISO 9000 standard or other kind of norms, directives. And in those directives is root cause analysis. So what we find as consultant in organization is that everybody is ISO 9000 certified. Everyone has a root cause analysis procedure, a complaint procedure in the quality manual. And guess what? It doesn't work because the mindset is wrong.
Yeah, so tools and techniques allow us to do things faster, cheaper, but they don't change our mindset. So if we are acceptability focused, tools and techniques get used to reinforce acceptability thinking. That's efficiency. Efficiency is doing things well, but it doesn't change what we do. Concepts and strategies, right? This is a different realm. And so these are a short list of quality management concepts and strategies, including the Deming philosophy. The majority of these are about focusing on what's bad to make it good, stopping at good. Concepts represent abstract ideas, fundamental building blocks of thoughts and beliefs. Strategies are how do we deploy them. So in the master course, which again is 2 8-week sessions, we get into great depth on these concepts and strategy for deployment. They offer effectiveness. The effectiveness is doing the right thing right. Tools and techniques don't get into that realm. And so in terms of resource conversion, what we're talking about is not just taking resources and converting them. Again, there's nothing wrong with tools and techniques, but what we're offering in the master course and master class is insights on how to improve effectiveness, which is challenging what we do, not how we do it, but challenging the thinking behind why do we keep doing what we're doing, which includes a feedback mechanism to constantly ask ourselves, are we moving further and further into all straw thinking, or are we falling backwards into last straw thinking?
To give another practical example, Bill, if I may, I know for a fact that one person in the audience goes to suppliers to manage suppliers, and it's very relevant to understand the thinking mode of a supplier. So they can all be ISO 9000 standardized or certified, and they can have all other sorts of certifications, and they comply to the root cause analysis paragraphs. But if the thinking is not correct, so then you get delivered not what you want. So in terms of supply chain management, pay attention to how you approach supply chain management. Do not look only for tools and techniques and certificates, but try to understand the thinking behind it with your supplier.
Well, and to that point, if you're using Six Sigma quality and look at these, the purple distribution has a very high CPK, but depending on the downstream consequences, it could be a very large loss. And so the effectiveness piece is understanding, is the ability to think past the CPKs and think in terms of things as a system. That is not embedded in the Six Sigma tools and techniques, looking at things as a system, because in those mindsets, we're focusing on the red lines, which are have we met requirements. All right, so now I'm going to give you a little sense of the economics and the opportunities for investment thinking. So this blue curve that Dr. Taguchi came up with back in the 1950s is most readily modeled as a parabola. And why is it a parabola? You can reach out to me and I'll give you there's some very good explanations for why a parabola is not a bad model. All right, and so the parabola says that the loss, right, is equal to else. First of all, there's a target value. M is the ideal value, right? And we're looking at the loss at target, which is the bottom of the curve, the ideal place to be. And then there's a K. K represents the steepness of the curve. And then Y is the quality characteristic, how far we are from the target value. Now, the proposal is when we're at home in the garage cutting that piece of wood to a given length, when we draw the one line and aim for the line, what we're doing is essentially operating with a sense of this blue curve that if I'm a little bit too long, a little bit too short, then I have to do the extra effort. And the only question is how much extra effort is there, right? In a Laster organization, you're not watching what's going on. It may not happen, at your site. It's somewhere downstream. Somebody is, as Jeroen is talking, banging it together. What is that? That's an indication that the curve is steep. So this is the mathematics behind the loss function, which Dr. Taguchi was honored for by the Japanese in 1950 with a Deming Prize in 1960. So what he's talking about is the blue curve, and he's also talking about in this single piece equation is that, the single piece equation says for every value of Y, you can calculate the loss. So you can go to the equation, put in the Y, you know the ideal value, you can calculate the loss. So one for one, you could say, if I use this piece, I'm going to spend an hour in assembly. This piece, I'm going to spend 2 hours in assembly. Well, what if you've got, instead of one piece, one piece, one piece, what if you have a distribution with 100 pieces, 100 tubes? So now what you do is you calculate the loss for the first tube, the second tube, the third tube, all the way through. And there's a bit of algebra here. And again, if you'd like to see the algebra, send me a note, reach out to me by email or LinkedIn. I'll show you the algebra. But what's neat is, if we're looking at a distribution which has an average and a standard deviation, then the average loss for each of those pieces is the L sub m, the loss at target, right, plus a K value, which is the steepness. And what's inside? Standard deviation squared and average minus target quantity squared. So there's two major components of the extra effort downstream. Some of it is associated with the loss due to the standard deviation. That's this sigma squared. The other piece comes from the bias, which is the offset. All right, so there's two major components of loss. Standard deviation, if we make that smaller, we can improve the overall loss. We can also, by focusing on moving the average to the target, that's another mechanism for reducing loss. So if the distance between the control limits is 6 standard deviations, then that means the distance between those dotted lines is roughly 1 standard deviation. And this is the economics of managing, according to Dr. Taguchi and Dr. Deming, is if you've got this offset, the big yellow distance, average minus target squared, that's a part of the overall loss. And the standard deviation squared is the other part of the overall loss. All right, Jeroen, back to you.
Yes. There we go. Next slide.
So there's two components of loss. One is the bias squared, and the other is the standard deviation squared. And what we're asking here is, if you look at the curve I just showed you and compare the standard deviation squared to the bias squared, what is that ratio? What is the ratio of the bias squared to the standard deviation squared?
It's a pretty advanced question for the late afternoon on a Thursday,
Yes.
so some mathematical you were not prepared for. But let's just give it a try. It's not a matter of good and fault. It's a matter of trying and learning together. What do you think? We have one participant who dares, Bill, so I can imagine that. So
Okay, that's okay. But the answer is about right. If you take the length of the yellow curve, which is the average minus target, take that length and compare it to the standard deviation, that's approximately a factor of 10, which means relative to loss, 100 to 1. And so what does that mean? It means the majority of the savings in putting things together, the majority of the savings in integration comes from doing what? From moving the average to the target. That's where we should put our energy. Not making the standard deviation smaller. And this is what I reinforced at Rocketdyne. Let's get our processes in control, get a sense of the downstream consequences. And if we just spent time moving average to the target, that pays for a lot. But further improvements in standard deviation may not be worth the effort. Which goes to show what? When you're going from low accuracy, low precision, to high accuracy, high precision, where's the money? The money is, it could well be that there's plenty of money just getting high accuracy. Maybe it's not worth the trouble of getting high accuracy and high precision. That's what I was trying to show there. Is the idea is that in Six Sigma quality, we talk about everything should be Six Sigma. Where's the six come from? How much money are we going to spend to achieve it? All to focus on acceptability. Here, what we're saying is the role of the economics here is that if we spend our time being proactive, we could prevent problems from happening and then simultaneously look for opportunities to improve integration. But there's a financial aspect. All right, so I want to close with an application from literally 30 years ago at Rocketdyne. It was a $500 million effort to develop the R68 engine, which is no longer in production. This is the, I consider this the machine that changed my world when people took the ideas I'm sharing with you and applied them to this brand new engine. I mean, they also applied them to the Space Shuttle Man engine, but what was really game changing on the Space Shuttle Man engine, we're applying these ideas to fix what was broken. On this engine, we're applying the ideas to improve integration. So this engine is about 18 feet tall. 3 of these engines would power what was then the Air Force's heaviest lift launch vehicle. In the combustion chamber, there is a plate. Think of a roughly 30-inch diameter plate, maybe half an inch thick, roughly. I can't show you exactly the geometry, but what I can share with you is that this plate had 628 holes, roughly 2 millimeters in diameter, and there's 628 of them. All right, so there's an outer ring, a next ring, a next ring, a next ring. And the design the engineers had in mind was to machine these holes and then put an injector into each hole, and then through the injector flows liquid oxygen and liquid hydrogen from the top of the plate to the bottom. On the bottom is where they come together with a spark and you get flames and you get combustion, and then you see the flames coming out. That's on the bottom of the plate. We don't want the combustion to happen on the top of the plate. So when these are joined, brazed foil, a very thin piece of metal, is put in between these two, and it melts just like the cheese in a grilled cheese sandwich melts. And in the melting process, you seal the joint, you get a fillet on the top and on the bottom. That's what we're trying to do. The challenge was, prior to 1996, we did not know how to get every single fillet in one cycle, which means what? Which means we have to braise again and again, and each braise cycle was roughly $15,000. And so the experts were saying, this design won't work. You have to go use a more expensive manufacturing process. All right, well, in experience, prior to 1996, if we look at the whole diameter, what we found is classic last organization. The machinists make the holes as small as possible. Why? Because you can always make them larger, right? And the machinist is not thinking about the tube that goes in the hole. The machinist is thinking about the hole in isolation. The person focusing on the outer diameter of the tube that goes in the hole and its outer diameter, what are they focusing on? They're focusing on making it as large as possible because you can always make it smaller. That's classic last straw thinking. And that prevented us from brazing everything in one cycle. So we started to focus on is, who owns the gap? So the hole people, do they own the gap? No. The outer diameter people, do they own the gap? No. Well, the engineers I trained focused on the gap, found out what was the ideal gap, and then instead of getting holes on the low side, outer diameters on the high side, they got really nice distributions and aligned them to achieve the gap that we wanted, that we never thought about. That is thinking we do at home in the garage. Because at home in the garage, we are the ones making the tubes, making the holes, and putting it all together. By focusing that way, we achieved every single cycle. In every single cycle, we achieved 100% of the fillets. All that extra work went away. This is one example of snap fit thinking on this engine. Another example that I can't get into the details, but by focusing on ideal values, not only did it go together better than ever before, saving millions of dollars over the program, but the engine performed with higher efficiency, which means what? Which means more performance from the engines by focusing on how they came together. So it was twofold improvement. And what we did was a major shift from minding parts to minding gaps, focusing on the relationship. And this thinking within Boeing became game-changing as people began to realize that we can apply these ideas to how we make rocket engines, how we make airplanes. So that's what's missing from these indices. We talked in the beginning about ACOF. This is module, the first session. The characteristic way of management is to manage the parts in isolation. And then Russ says, and if that's done, the system behave well, and that's absolutely false. So what I tried to give you a sense of, with great insight from Jeroen's experiences, what does it mean to shift from managing parts to managing how they come together when we think it's worth the effort? So I want to leave you with these thoughts. Imagine the possibilities when operating in an all-straw organization, which we also refer to as a we environment. Organizations as unusual. We focus on how are we doing. This is how we manage resources with a focus on tools and techniques guided by the effectiveness of a systems view. The extra effort of the influencers of these three gentlemen. Imagine if more organizations could develop a broader appreciation of continual and connected learning, a deeper appreciation of what it means to work, learn, and think together. Togetherness is an all-straw concept, right? Focusing on your part is not about togetherness. So closing thoughts and practicing organizations as usual. Resources are allocated to firefighting, lowering things gone wrong, fewer defects. Under such contingent, waiting for it to happen, how much value is given for prevention? Not very much. If not seeking opportunities for investment, where efforts to improve interactions between the components could have a potential serious superior return. Organizations as unusual, guided by Dr. Deming's distinctive theory, offers unlimited opportunities to both prevent problems and seek opportunities for investment. Okay. That's what we wanted to share with you in these three sessions. Back to you, Jeroen.
Lovely, lovely. Thank you very much, Bill. Wonderful. Listening to this all, you get to realize that the practical reality is always a little bit more difficult than what you see on the slides. But anyhow, I hope you get the sense of the message and how you can move forward, improving your organization. So let's see if there are some final thoughts or questions. And I can imagine you have to go to the next meeting. We're a bit over time, but it's all okay. Is there any question related to this topic? Practical experience? Jamal?
Bill, can you hear me?
Yes?
Yes.
Okay, great. So we are having a bit of a discussion here between my colleague and me.
Oh, good.
Because he said he doesn't accept that the people that work at these rocket companies are so extremely intelligent and still they can't seem to make stuff fit together in the way that it should fit together.
That's a nice one.
So apparently, in my mind, it's apparently not so obvious that you need to mind the gap and that what is actually the definition of intelligent? What does it say? So can you elaborate on that, Bill?
Well, the proposal is, I mean, what happened was hundreds of people were exposed to these details, and a handful of them really believed it and did something with it. And they went off and took the examples of cutting a piece of wood at home in the garage to the ideal value. I mean, they were willing to buy into maybe there's a limit, maybe there's more to do here. And I'm not saying all of them did that, but a decent number of them took that to heart. I am still in touch with them, still working closely with them. And for them, it was game-changing, life-changing to manage a system. And managing a system is not what most engineers do, nor software developers do. They look at things in isolation and rarely appreciate the extra effort required of others to put these components together. But what was fascinating is when senior management within Boeing saw the difference, then they got very excited about getting these ideas elsewhere within Boeing. And again, I'm not saying everybody bought into it, but enough people bought into it that I was traveling across the country every week sharing this with people who wanted to shift the way Boeing managed from managing parts to managing a system. And that alone kept me busy for the majority of the 9 years we were owned by Boeing, is the people who found this exciting kept me very busy. The people who failed to appreciate this kept doing business as usual.
Absolutely. And that is what we experience kind of like daily in our consultancy and education practice with companies. So I like the interesting question, Jamal, to talk about intelligence. Well, the question is it about intelligence? I mean, it's more about your mindset and by understanding and seek the cooperation together, because we give here in a simple example of two pieces together, but the whole machine has a million different parts together. So all those departments need to work together. So if you have one or two or three departments that have a different mindset and do not cooperate and do not understand it, your whole plane doesn't take off. So it's a major change in the organization to get everybody on the same page. And that's not, apparently not easy.
No, and what happened was, Jamal, go back to you, is the people who took this seriously, who worked in this combustion chamber, they took this thinking wherever they went within Boeing. And the others kept doing what they were doing. So they'd be sitting on opposite sides of the aisle, the people developing hardware, which we banged together, sitting across the aisle from the people who were developing snap fit. And the challenge was that management knew the difference, but we just had a really hard time getting more people to pay attention, because we don't want to force them to do this. We're trying to inspire them to do this.
Yeah. Can I give I was very late because I missed the summertime. Can I give a practical example of parts together?
Please.
I was just telling the story today to other people. We had, on a certain moment, we had a problem with engines that the fuel pumps, the high pressure fuel pumps, get sized. And we had a specialist, of course, in that company. And he was telling that it was a running in problem, but I didn't saw that because the way it happened, there were no reasons to assume that. So when I start investigating that and start looking in the history, I have found that because fuel pumps, high pressure fuel pumps, okay, it is a story, maybe not for everybody, but they need a circulation of the fuel over the high pressure fuel pumps. And the thing was, they had increased during the years which happened in the past, nowadays very difficult. If an engine is increasing, for example, 10%, it needs complete redesign. But in those days, engines, there were classic engines, they start from 50 horsepower per cylinder and ended with 300. That is now no more possible. But this was also significantly increased. And what happened is that I found that the circulation pump was never increased. So the size of the circulation pump was the reason of the high pressure fuel pump. But everybody focused on the high pressure fuel pump, but not on how the parts work together. So maybe this is a practical example. Yeah.
Nice. Very nice. Yes, thank you for sharing. Yeah, wonderful. All right, we come to an end of this webinar. We're over time. Thank you very much. Please keep in mind that on the 7th of May, we have our event. On the 20th of May, the webinar master course starts with more of this material. Hope you enjoyed it, and maybe till next time.
Guys.
Thanks, everybody.
Bye-bye.